So students, earlier we have learned in the previous session, yes, regarding the natural numbers, the whole numbers, integers, and what we have discussed, yes, the main topic, that is the rational numbers, right? So what are rational numbers? Yes, the rational numbers are the numbers which are in the form of p by q form, and where q is not equals to 0, and where p comma q are what? Integers or whole numbers? Yes, exactly, they are integers. That means the negative terms are included in it, right? So now let us discuss what? Yes, the rational numbers, how we are going to express on a number line, right? Yes. So students, how we are going to express the numbers on a number line? Yes, earlier you might have learned how to express the numbers on a number line. Let's recap. So, what is a number line? Yes, it is a array which contains, yes, 0 as a middle term, right? And the positive to the, yes, right side will be positive and the left side will be your negative terms, right? So, I am going to denote the positive elements are what? Yes, 1, 2, 3, 4, 5, so on, right? So, these are the right side numbers on a number line which are indicated with the positive, yes, numbers. And next, to the left, what we are going to write? Yes, minus 1, very good. Minus 2, minus 3, minus 4 and so on, right? So, this is what we are calling it as a number line. So, if you are going to, yes, let's say suppose, where is the number 3.2? So, how do you denote? Yes, 3.2 is where? 3 after 1, 2, 3, 4, generally we will have 5, right? So, 3.1, 3.2. So, this is where you are going to denote the number 3.2 on the number line, isn't it? This will be in a decimals. So, generally now in the fractions, so how do you denote? So, I am going to give you a number 1 by 2. So, where you are going to denote, students? Yes, 1 by 2 is what? Yes, it is half. Where is half? Half will be between 0 and 1 and it is a positive. So, where it will be? It will be in the right side on the number line. So, between 0 and 1, you are going to have the, yes, number 1 by 2. So, this is what your indication will be on a number line, right? So, now I am going to give you another number. So, that is minus 1 by 2. So, where you are going to denote this minus 1 by 2 on the number line? Yes, exactly. So, it will be, yes, in between 0 and minus 1, right? So, this minus 1 by 2 is what? It is less than minus 1, right? So, obviously, it will be between 0 and minus 1. So, where it is going to be? Yes, exactly in between of the 0 and minus 1, you are going to denote minus 1 by 2. So, this is how you have to denote the p by q forms, that is nothing but the rational numbers, yes, on a number line. Got it right? So, how do you denote the number line? Yes, how do you denote the rational numbers on a number line? By checking where it is going to line, in between what numbers the given number is going to line. So, now I am going to give you some numbers you have to indicate on a number line. Okay? Yes. So, this is the number line, right students? So, how you indicate? 0, 1, 2, 3, 4, so on. And next, to this side, yes, obviously it will be negative. So, 0, minus 1, minus 2, minus 3 and so on. So, now I am going to give you a number. So, what number I am going to give? A rational number. Okay. So, minus 3 by 2 is a rational number. So, exactly where it is going to be? Can you tell? Okay. Yes, correct. So, minus 3 by 2 will be in between minus 1 and minus 2. How I can say between minus 1 and minus 2? Because, so, minus 4 by 2. Minus 4 by 2 is what, students? Can you simplify? 2 ones are 2 twos are. So, minus 2. So, this minus 4 by 2 is obviously, yes, So greater than minus 3 by 2, right? So obviously it lies between minus 1 and minus 2, right? So minus 3 by 2 it what? Yes, it lies here, minus 3 by 2. And what all numbers can lie between minus 1 and minus 2? Can you see? Yes, obviously it is minus 1, minus 1 by 2, minus 2 by 2, sorry. So minus 2 by 2 is what? Nothing but it is minus 1. Okay. Next, minus 3 by 2 and minus 4 by 2. So what all numbers can it lie? Yes, it is minus 2 by 2, minus 3 by 2 and minus 4 by 2. Right? So can minus 5 by 2 lie between 0 and minus 1? No, it is greater than these numbers. Right? So obviously what are the numbers? Yes, these are the numbers which are going to lie between minus 1 and minus 2. Understood, right? So now any number, any rational number if I am given, you are able to do on a number line, isn't it? So generally you will get confused with the negative numbers only, whereas positive numbers is very easy, right? So positive numbers is what generally, where is 3 by 2? 3 by 2 where it is going to lie? Yes, it is between 1 and 2, right? Yes, obviously 4 by 2 is what? 2, right? So obviously 3 by 2 is less than 4 by 2. So obviously, right? So 3 by 2 lies between 1 and 2. So that way you can easily check. Clear, right, students? So clear, right, students? Yes. So 3 by 2 lies between 1 and 2. So 5 by 2 or 7 by 2, 8 by 2, that all we can clearly lies between the numbers, you can clearly check. Okay. So do it as an exercise. It will help you greatly to solve the problems quickly. Okay, students? Okay. So this is what the topic on the rational numbers on a number line. So how you are going to identify the numbers between the number line, you have to know. Okay, clear? Yes. Now the next topic we are going to learn is rational numbers in a standard form. What it is, let's see. What we are going to learn? Rational numbers. Yes, rational numbers in standard form. Yes. So, ma'am, I know about the rational numbers, I know the equivalent numbers. Yes, many things. But what exactly is the standard form? You might have got in the confusion, right? So, nothing to worry. Standard form is nothing but it is what? It is a simplest form. Okay? It is nothing but simplest form. You all know already. Okay. So, let me give you an example. So, what is rational numbers? Rational numbers is P by Q form. So, generally, if I take the value 15 by 20, okay. So, can I express the complete P by Q form in simpler way? Yes? Yes, I can. So, that simpler way is nothing but it is the standard form. So, how you can express? Yes, by taking the common number to cancel out. So, 5 3s are 15, 5 4s are 20. What is the value? 3 by 4. So, that means you have to get what? You have to get what? Yes, you have to get only one common factor. Only one common factor to the numerator as well as the denominator. So, what are the common factors for 15? So, 15 has the common factors as, yes, 3. So, does 2 has a common factor for 15? No. In 2 table, 2 sevens are 14 but not 15. And next table is 3 table. So 3 5s are 15. So we are going to get 3 as a common factor. Next 4, no. 5, yes. And any other table? Yes, 15 also. Right? So what are the common factors for 15 now? 3, 5 and 15. Next, let's take the next number, denominator, 20. Right? So for 20, what are the numbers? Yes. 2 tens are 20. Yes. Next, 3 table? No. 4? Yes. 4 5s are 20. Next, 5 4s are 20. Next, 6 not. 7 no. 8 no. Next, 9 no. 10. 10 2s are 20. Right? Yes. So, these will be the common factors. That means, these are the numbers which have more than one common factor, isn't it? Right. But, when you see the number 3 and 4, so 3 has a common factor? No. But 4 has a common factor, that is 2 and also, yes, I can write 4, right? So, but here the denominator has more than one factor, whereas the numerator does not have more than one factor. So, both should not have, yes, more than one factor. Sorry. Any of the one, that is either numerator or denominator, can have more than one factor. So, till then you have to say that it is in the standard form. So, understood, right? So, standard form is nothing but, so both the numerator and the denominator contains, yes, a common factor. Okay, only one common factor you can take. So, that is nothing but standard form. Can you people give any other numbers which I can convert into the standard form? Yes. Example, I can take minus 30 by 20. So, can I take? Yes. How you will reduce? Yes. Reduce into a standard form or convert into a standard form or convert into a simpler form. All these, yes, comes into the same question. Understood, right? So, how do you do? Yes, 0, 0 gets cancelled. Yes, simply we can write this is minus 3 by 2. So, can I still reduce minus 3 by 2? No, this is the final one. So, minus 30 by 20 is the standard form is minus 3 by 2. Clear, right? And the sign will not change. Sign will be as it is. So, this is nothing but the rational numbers in standard form we are going to express. Okay, clear? Next. Now, let's discuss about the like fractions and unlike fractions. Okay. So, what are like fractions, students? Let's see. So, like fractions are nothing but when you have a common denominator for both the numbers, given numbers. Okay. For example, I can take 2 by 3, comma 4 by 3. So, now I can say these two are, yes, like fractions. That means they will ask how, yes, whether 2 by 3 is greater or 4 by 3 is greater. So, how will you write? Yes, when the common denominator is there, then you can compare both the numbers, isn't it? So, now we have the common denominator here. So, that's the reason we can easily compare the numbers, that is 2 and 4. Which is greater? Obviously, 4 is greater. So, 2 is less than 4 or 4 is greater than 2, I can write. So, it is easy to compare when the given fractions are in what? Yes, like fractions. So, like fractions are nothing but both the denominators, yes, both the given number denominators are equal. Okay. So, now you will say what are unlike fractions. So, students, what are unlike fractions? Yes, unlike fractions are those numbers where the denominator will not be equal. Okay, that means I can write 5 by 3, comma 8 by 2. So, now can you say which number is greater? That is, which rational number is greater? Can you say it easily? No, it is somewhat difficult, isn't it? Why? Because here the denominators are not same. So, what we have to do in this case? Yes, now we have to convert the given denominators. That means we have to make the denominators equal. So, how do you make the denominators equal? By taking the least common multiple. That is what? LCM of the given denominators. So, how do you take the LCM, students? LCM of 3, comma 2. How do you do? Yes, you all know, right? So, 3, comma 2, these are, yes, these have common factors. That means 3 into 2 is 6. So, the LCM will be what? 6. So, now what we have in the denominator? 3. So, 3 2s are 6. So, 2 into numerator, what is the numerator? 2 into 5 plus, sorry, 2 into 5. So, this is a one number, right? So, 2 5s are what? 10 by 6. So, the first number we got what? 10 by 6. And for the next number, 8 by 2. So, what is the denominator here? We have 2. And what is the LCM? We got 6. So, 2 is what times of 6? 2 3s are 6. And 3 into what is the numerator we have? 8. 3 into 8. 8 3s are 24. By what? 6. So, now if you see, both the denominators are what? Equal. Right. So, when the denominators are equal, it is easy to compare the numerators. So, now 10 is greater or 24 is greater? Yes, obviously 24 is greater. So, we can write 24 is greater than 10. So, unlike fractions are difficult to compare the given rational fractions. So, that's the reason what we have to do? Yes, we have to make the denominators equal. Okay, that means we have to make the numbers as like fractions. Clear, right? So like fractions are what? Yes, like fractions are where the given rational numbers in which the denominators are equal, we are calling them as like fractions. And whereas unlike fractions are where both the rational numbers are, the denominators are not equal, and then we are going to convert, that is make the denominators equal. Okay, clear, right? So these are nothing but the like and unlike fractions. You might have studied in your previous classes, but to a recap, I have explained here. So these are the fractions. So these fractions are used mainly in the rational numbers. Okay. So students, now let us discuss an important example before we go to an exercise problem. Okay. Yes, let's do. So do 4 by minus 9 and minus 16 by 36 represent the same rational number. Yes. So if you have listened the previous concept clearly, you will have, yes, you are going to do the problem quickly. So how many of you have got the answer? Yes, very good. So do 4 by minus 9 and minus 16 by 36 represent the same rational numbers. How do you check? Yes, by comparing, right? So 4 by minus 9 and what is the other number? Minus 16 by 36. So first what we are going to do? Yes, we are going to reduce into the standard form, right? So how do you reduce into the standard form? Yes, by taking the account of, yes, by reducing into the standard form, right? So this is how you are going to reduce. 2 2s are 4 and the number here in two table we are not going to get. So you have to take the common number. This you have to remember. Okay. So here this 4 by 9. Okay. So this 4 by 9 is not going to cancel in both the numbers, right? So let's keep the same number 4 by minus 9. So now here we are having what? Minus 16 by 36, right? So can you get cancel here? Yes. 2 8s are 16, 2 1s are 2, 2 8s are 16. We are going to get 8 by 18. And again you have to simplify. 2 4s are 8, 2 9s are 18. So what number you have got? Yes, 4 by 9 and negative. So here they have given the negative. Don't forget to keep the sign. Okay. So what are the first number you have here? Yes, 4 by minus 9. 4 by minus 9 is how I can write? I can write minus 4 by 9, right? So minus 4 by 9 is the first number. What is the next number you have reduced? Yes, the reduced number you got it as minus 4 by 9. So now minus 4 by 9 is equals to minus 4 by 9. So are both the rational numbers same? Yes. So what is the question? Yes, both the given numbers represent the same rational numbers. So this way you have to solve the problem. Hope you understood, right? So we are going to do some important exercise problems in the coming classes. Okay. So students, in this session what you have learned completely about? Yes, the rational numbers, how you are going to represent on a number line, isn't it? So in the number line you have both the positive and as well as the negative numbers, right? So whatever the given number, rational number, where it is going to lie, in what numbers it is going to lie, you have to represent on the number line, right? Next, what we have studied? Yes, we also studied how to reduce the given rational number into a standard form. So how we are going to reduce into a standard form? We are going to take the common factors, right? So by taking the common factors and cancelling out, yes, the given rational numbers, we are going to reduce into a standard form, right? So this is what we have clearly learned. And next we have also seen about the like and unlike, right? So what is like rational numbers or unlike rational numbers? Yes, we have seen the like fractions are nothing but we are going to use the like fractions in like rational numbers. Like what? Yes, the denominator should be same. Those are taken into consider as like fractions. and when the denominator and when the denominators of the given two both numbers are not same, then we are going to make it a same by taking the least common multiple of both the given numbers. Clear, right? So these are all the important concepts in the rational numbers. So these rational numbers, where we are going to learn? Yes, we are learning it through the complete number system, yes, chapter, right? So number system includes these all the things, right? So number system includes the natural numbers, whole numbers, integers, rational numbers and many other. Right, students? Yes, this complete rational numbers is very important concept for you, and this is the basic fundamental thing so that you can learn more in your higher classes if you are well and good in the lectures now you have listened. Okay, clear. Hope we are going to continue the next classes, that is taking the exercise problems clearly in the coming sessions. Thank you.